Morning, everyone. Morning. Hello.
Sir, we're hearing you.
Good morning.
Okay, good. I just want to know that you're there.
Morning, sir.
Morning, morning. Let's just wait a little bit for more persons to log on a little bit. But in the essence of time, as you can see my screen, these are the objectives. Hopefully, I will be able to can cover all of them because I believe we only have 1 hour to do this lesson for today. Right?
Sir, what was the topic?
What do you mean?
As in the topic for the lesson?
Are you not seeing my screen?
Yeah,
Are you able to read what's there in terms of the objectives?
yeah. Is it just circuits then?
Pretty much, yeah, it will be that. It will be circuits still. We're still on the circuits in a sense. But we're going to talk more about, some protective devices that are used inside of the circuits. Take, for example, your fuse, your circuit breaker, and your grounds wire. All right. Good. So the first objective here that we want to cover is to discuss the reasons for using parallel connections. I would believe this is to be for domestic appliances. So that's the first objective. The second one would be to explain the purpose of a fuse or circuit breaker and the earth wire. Then the third one would be to select a fuse or a circuit breaker with suitable current rating for a given appliance. All right, and the other one would state the adverse effect of connecting appliances appliances to incorrect or fluctuating voltage supplies. Now, the question would be for you guys to think about the first.
Sir, I was writing the objectives.
Oh, you're writing. My apologies. Go ahead. I can save you some time by telling you that these are the objectives that came from the syllabus. So if you look under the section that talks about electricity in the home, you would see the objectives.
Okay, sir.
Right.
What about the rest of the notes? Are those directly from the syllabus as well?
No, the objectives comes from the syllabus, right? I can't say the notes. There's no really notes in the syllabus. The syllabus only provides us with the things that we need. All right.
Okay. So will we get time to write the notes?
Yeah, man. Some aspect of the notes, well, I can't tell you to write it, write up everything because there's going to be a lot of notes, right? But important points you can write them down until I'm able to upload this video. The video takes a good while to upload, by the way, guys, and to kind of do a little bit of editing to it. It takes some time.
Right? Okay, sir. Thank you.
Yeah, but don't rely so much on the videos, so to speak, though. Right? I want you to take little notes. With the notes that you take, those will stick in your memory. All right. So now the first objective is talking about parallel connections. Right? I think last class we made mention of a few reasons why we would want to connect our appliances in parallel. Can anyone refresh my memory, or from the fact that from the whole parallel circuits, what do we know about parallel circuits in the first place?
So it's not like the series circuits where the components are directly, what we call it, in line or directly beside each other. You kind of say they're separated. So, yeah.
Okay. No.
Current. Oh, you want anything else, sir?
Go ahead, miss.
Current is split and voltage is constant.
Okay. And with that bit of information, what do you think? What conclusion can we draw from that? Now that you said that current is divided and your voltage remains constant, what let's take it a notch now to your household appliances. If I am connecting my household appliances in parallel, right? What do you think is going to happen there?
Sir, probably the voltage for each appliance has to be different now, since each appliance takes a certain amount of voltage to be powered.
Hold on. Remember, with parallel circuits, the voltage remains the same, right? But is now the current that is divided. That doesn't change, all right?
Okay, sir.
Yeah. So what really takes place, you see, there's a huge advantage with parallel circuits, and that is as a result of the fact that, you know, when one device is off, it does not affect the entire circuit. And let me go back to my screen here to show you this thing. Oh, seriously. Right. Now, here is a circuit that I had designed online, right? This is a parallel circuit, good, where my light bulb here is connected in parallel with another light bulb. Mind you that both of them have the same resistance, good. Now, if I'm supposed to close this switch, right, I will expect my light bulb to come on, right? With this switch being open here, it does not affect this first light bulb, if you see what I'm saying. So when you connect things in parallel, it does not affect, you know, other components that are connected in parallel with it, right? Seeing that the current is divided, the current will just go in the path where it needs to go, and it would avoid the other part that, you know, it does not want to go in, wherever there's a short circuit here. Now, in a series circuit, if everything is connected in series, I should have made a series one, but I didn't make that one. If I have it in series now, once one part of it is broken, then no current is going to flow to the other components. You understand? So that is what would take away from the efficiency of that type of circuit. While it is a good circuit to use in some instances, right? But you know, it's not gonna make it efficient in our household. Now, if I close this switch, there's another thing that takes place here, right? Because the voltages are the same, or should be the same. I'm not sure what is happening with this circuit. I realized that the voltages are, when I took the measurement, they're not the same, but they should be the same. They should have the same voltage drop across the two light bulbs. With that being said, now, it means that both bulbs are going to have the same brightness, right? So that's one of the beautiful things about parallel circuits. If it was a series circuit, what you're going to find is that you're going to have different brightness of the bulbs, because we know in a series circuit the voltage is divided, right? So the voltage is going to divide itself right across the board. Okay. Now, here are 4 things that I want you guys to take note of, right? The first one would be that in a parallel connection, you can have independent components, meaning that, you know, they work independent on their own. So just like with the light bulb a while ago, when I opened the switch of one of them, the other one was able to work on its own. It does not rely on another component for it to work, right? Okay. But as you can see on my screen, it says, in contrast with a series circuit, you know, if they were in series, you would find that one would rely on the other. So if one got damaged in the process, the other one won't be able to work. All right. Now, number 2 is that it has consistent voltages, which means now that each component is able to get the same amount of voltage that comes to your house. So if your house is wired up for a 110 volt, it means now that every appliances in your house is going to get, you know, a 110 volt, right? But mind you that, you know, each appliances have a different current rating, right?
Sir. Sir.
Go ahead.
I was just about to ask something like that. If like in your house, the bulbs are able to only manage a certain amount of voltage, but yes, still it's a parallel circuit, and you said in a parallel circuit the voltage is the same, which means that all the bulbs gonna have the same brightness. What if one of the bulbs carries a lesser light then because of the amount of voltage it can manage? What would you say about that?
All right, so you have different types of bulbs, right? But let's imagine that, you know, all of your bulbs in your house is a 100-watt bulb, right? Now it means now that every bulb should have the same brightness. You understand? So, you know, typically you would have maybe a 60-watt bulb in some part of your house, and you'd have a 100-watt. You understand? Now, you know, all the bulbs are working to their best capacity because that's what they're rated to work at. All right. I don't know if that answered your question fully, but let me know.
Yes, sir, I understand.
Yeah. All right. Now, another thing here, it allows for additional components, which means now that you can, you know, add other things to your circuit without it interfering with anything per se. So if I wanted to go back and adjust my circuit to having 3 light bulbs, then it wouldn't affect, you know, the price of rice. The bulb would still have its same brightness, right? Providing that, you know, there is the power source, you know, is there to be able to kind of give it the requisite amount of voltage that it needs. Right? Whereas now, if you are looking at a series circuit, if you're comparing both of them, you know, as you increase your components, you're increasing your total resistance, right? Which means that it's going to you know, have a different voltage drop across each component. So everything is going to just dim down until maybe one of them, you know, basically don't show because the resistance is being increased overall. And as your resistance increases, your current flow is going to decrease. And we can look at that from our Ohm's formula. All right, seeing that they are inversely proportional. All right. The fourth one is that, you know, it's reliable and it is much safer, right? In the sense that, you know, to design a parallel circuit, it makes life much easier, you know, less complicated. Components can be easily added and subtracted if you want to look at it from that standpoint, right? So important to note that, guys, if you're going to do electronics in the future, whatsoever it is, right? It's best that you design your circuits around having a parallel situation when it is needed, all right? So that, you know, all the components can benefit from this whole thing. Our person's taking notes, by the way.
Yes, sir.
Yes, sir.
Let me see how many persons are here. Only 11
Right,
persons.
can go to the first point, please.
1 second. So, you know, with the first point here, looking back at it, I realized that it says that, you know, each component can have their own switch. Just like with my circuit a while ago, that light bulb had its own switch. When I flipped that light switch, it did not affect, you know, the other one. So you're more able to have a better manipulation or you know, more